So this is an oscilloscope here. There's a brightness control here. We can turn up the waveform, and there's a time base. As I turn, you can speed it up or slow down the trace. So let me turn off the lights so we can see that trace. I'll turn off the TV. So now we have live electrocardiographic information. This is a heart monitor here, and it's streaming live to this web app here that's connected to the phone app. And also I've got an oscillograph here, and we can kind of compare the waveforms just as before. So we're prepared. We always have the shaver shave off first, and then isopropyl alcohol to scrub everything down, and then a little bit of sandpaper as well. And so finally a little bit of electrode paste, and we can put some electrodes on there as well. These are some electrodes, and I've got a cathode ray oscillograph here that will show the oscillographic waveform. And so now put a little bit of electrode paste on one of them is the ground, and this is nothing fancy, no driven right leg. We'll have the ground and then the two electrodes here, and pick up the signal, and we can compare it with what's here on that heart monitor. So I have here heart monitor, and this is not exactly centered, but it's pretty close, and then there's two electrodes here, so we're reading across this place here. Normally when you put on a 12 lead, you put on the right arm, right leg, left leg, and they can be sort of around here in this area. And then you've got your V1 through V6 across here, and you start in the fourth intercostal region here, and then you work your way to the fifth intercostal region. You kind of go around across and then around like this to put on the full set of electrodes. Usually you're looking at, you locate the clavicles, you locate the sternum, and you find exactly where to put them. And of course you can read all about that, where they go, and you've got your leads, you're going across the arms and legs. One of them is a ground or reference, and then you have the extremities, Eindhoven's triangle, that sort of thing, and then you're picking up these other ones that are right near the heart. You tend to get a stronger signal in close to the heart also if I connect this to the cathode ray oscillograph here. You can see I've got a waveform that picks up. The ground lead is not connected as well. I've got a little bit of noise there. Just a little bit more electrode paste on the ground lead. Make sure that makes good contact, because otherwise it'll be a noisy signal. And what I usually do is just leave it sitting like that. And we can actually use sticky electrodes that actually stay on. But now, so you can see right there, and a little bit more of this on here. Turn up the brightness a little bit so there's some persistence. So you can see there's my heartbeat on here, and I'll turn up the gain just a little bit. It's better. So you can see that waveform there, and it's in pretty close agreement with what we see on the screen there. This is the app that's streaming continuously, and this is the web app. So my cardiologist, for example, can remotely monitor my heart in real time while I'm running and swimming. So I'm streaming real-time video and also streaming real-time ECG, and we have the world's first context-aware heart monitor, because it streams the live video, and you can see what activities are taking place at the same time as you can see the actual electrocardiographic waveform. And so we hope that this context-aware information will help us to diagnose and improve our quality of life by being aware and sensing the waveform at the same time as we're actually able to see what happened in the environment, in the video environment. So today, for example, I went for a run and a swim, and we'll be going again each day whenever the conditions are safe to do so. I try to get out for a swim, get some exercise, and so we want a strong, healthy heart. And that's what one of my cardiologist friends said, that there's no such thing as too much exercise. More exercise is better. So anyway, that's kind of roughly how to set up the waveform, set up the electrocardiographic measurement, and we can take this data, put that into a file, comma separated values, read that data out, and overlay that on top of the eyeglasses. So the eyeglasses have a 4K 60p camera that records video at 4K resolution, 60 frames a second, and then we can overlay on top of that video this electrocardiographic information. Here, unfortunately, we have a white background, so that's not so suitable to overlay, but the way that it looks on the app is a lot more like the oscilloscope. So these two actually look pretty similar, and we can see, if you look at this more closely, you can see the heart waveform there streaming along, and you have a black background and bright green trace on a black background. So the background allows you to cement that trace on top of what you're looking at, and then you can sort of see this overlaid, and it's just like, you know, as you're running or whatever, you can see that electrocardiographic information overlaid. And we also have the mind. I've got the Blueberry brain sensing health monitor, so it senses your mind and your heart and the environment around you. So that's what we often talk about, heart and mind and world sensing eyeglass that helps us see and understand the world with these overlays. And of course, we've got this other wearable device. So we have, generally speaking, wearables, wearable technology that's monitoring our health and well-being. So ECG waveforms were originally made with very crude sort of measuring instruments that responded slowly. And the original labeling, they originally called these parts, A, B, C, and D, and so on. And then with better measurement instruments that responded more quickly, we had a sort of relabeling of the waveform, the shape of the waveform, the sort of this shape of the waveform kind of goes, like here it goes along and then down and then up and then back down again and then sort of another part over here. And this is called P, Q, R, S, and T, the sections of the waveform. And sort of historically, when we want to label something like in terms of labeling points like this, René Descartes, French philosopher from the 17th century, often would label, say O is the origin of the circle, the center of the circle, and then points along it would have some point P. Point P. P stands for point, and we'd have some point P. And then a lot of times if there's some curve, the next letter of the alphabet is Q and would be used R, S, and T and so on. So it's natural to begin with point P along this curve and then label the next points Q, R, S, and T. This is sort of Rene Descartes, famous for I think, therefore I am, is probably one of his most famous sayings. And he was kind of an individualist, he was sort of an anti-academic. And I really like the idea of his thinking. It's almost surveillant thinking, like the idea of ordinary individual people knowing what they know and defying what they learn in school and just learning, understanding what they know. And so Descartes had this way of labeling these points. And then going back to this early, the other thing we notice about this early system is it was done with saltwater baths. So you put your left foot in a saltwater bath and your right and left hand in saltwater baths. So there's 3 baths there, and measuring the voltages across them using these crude instruments, which would be a great big magnet that weighed about 600 pounds with a little wire running through it, and big electromagnet, liquid cooled, and then a piece of wire running through it. And this was a very sensitive galvanometer. These are sort of the early days, and even before that, it was mercury tubes that would respond rather sluggishly. But once the galvanometer was invented, there was ability to measure quickly the response. The left foot here is in the bath because the heart is on the left side of the body. So typically what we have when we arrange the heart is we have, when we describe how these leads are laid up, we often, we'll talk a little bit about Einthoven's triangle, which is, this way of thinking of the leads. So if we think traditionally from 1911, when we had the saltwater baths with the parts of the body in it, we have the left arm, usually it's called LA, and the right arm RA. And notice that we put the right arm on the left side of the drawing when we do it, and that's very convenient because we can put it, we can hold it up against our body like this, and then of course it's true to what we have, the way it is laid out. So it's almost like we're looking at a mirror image of it. So this is the left arm, right arm, and then we have the left leg. And now when we connect to the right leg, the heart is on the left side of the body, so we want to mainly think about the left. So we're going to connect with respect to the left arm, right arm, and left leg. These are the 3 points we're going to connect to. And then this point, the right leg, is used just as a sort of grounding reference to sort of reduce noise in the signaling, and there may even be a driven right leg. But what we have is sort of these 3 points here. And what we typically talk about is we put the on the left side you've got your positive, and on the right side you've got your negative, and this is called lead 1, this point of reference here. And then over here you've got the negative stays here and the positive goes down here to the left leg, and this is called lead 2. So we call this 1 and we call this 2. And then if we move over here, if we leave this positive down here and we move the negative over to here, if we put the negative over on the left arm and the positive down here, this is what's called lead 3. So we can see we have these 3 leads, and we can see the waveforms from those 3 leads. You see, when I'm looking at this here, you can see why it makes sense to put the right on the left and the left on the right, because when I hold it up against myself like this, I've got, my left arm, my right arm, and my left leg right here is on the left leg, and this is the right leg. So you can see here, lead 1 is here, and lead 2 is here, and lead 3 is here. So it makes perfect sense the way it's written in that diagram when you hold it like this against yourself. So we can see those waveforms. Let me peel down for this. We can see those electrical waveforms if we look on the cathode ray oscillograph here. And I also have a more modern allegoscope here. An allegoscope is something that alleges to be an oscilloscope. So now we're going to, if we look at those waveforms as they are, we can probably see them to some degree. And now I've just got some electrode paste here, which I'll put on the on the right leg. So that's going to be here, and then the left leg, it will be one of the inputs. And so now let me turn down the light here so we can see that waveform a little bit more clearly. And now I have some electrode paste on here to make good conduction again. And you can see the different kinds of waveforms present. And if I take this and put it left arm and right arm here, I can see a little bit of a waveform. Hang on a second, I've just got to turn on my preamplifier. And now I have my preamplifier set to a gain of exactly 10,000, and the oscilloscope's 1 volt per centimeter. And now you can see the waveform there. And so you can see the electrocardiographic waveform and the general shape of the waveform as a function of time. And what we have is about 2 seconds across, so it's 0.2 seconds per division, 200 milliseconds per division, and there's 10 divisions across the screen, so that is equal to 2 seconds across the whole screen. And so that's what it looks like when we go from here to here. Now, let me take it a little bit higher. Traditionally, your right and left arm electrodes are actually up here, and so it's a little bit harder to get a good clean signal a little bit further from the heart, and that's why a lot of heart monitors, exercise heart monitors, and that go right along below the heart. But if I come up here a little bit further and I'm perfectly still, you can see that electrocardiographic information there. Let me move that trace up just a little bit. So you can see that trace there, that waveform from left arm to right arm, with the positive lead on the left arm and the negative lead on the right arm, negative wire, a conductor for lead 1. And now if I take so that's lead 1, and then lead 2. So I'm going to leave the right arm where it is, the negative lead, and I'm going to bring the left arm down to the left leg. Lead 2, the right arm stays, and the left, we go down to the left leg. here, down near where the left leg is. So this is lead 2, and you can see that's lead 2. And then if I take, at this moment, if I leave the left leg right where it is, and lead 3 is left leg positive and left arm is negative, so I move the negative over to here. And so you can see that wave shape. So wasn't that a lot of fun? So now if we look at what that actually means here, let me turn the light back on here. And so if we look at what we have here is basically we've got right arm, left leg as sort of, there's a kind of a vector pattern that takes place here. And so what we can think about is, just grab another chalkboard here and say, okay, we have, think of it this way, we can write, oftentimes people write, you know, I equals LA minus RA, and we'll write I equals, and this one here is equal to LL minus RA, and I equals, this one here is equal to LL minus LA. So we can kind of write these as, you know, sort of, we think of them as vector equations. And then, of course, the other thing that cardiologists often do is to take to consider the component due to each of these. So if I take, for example, the average of left leg and left arm, which is here, and then what cardiologists often do is they take and form these other vector quantities, which is take the average of left arm and left leg, for example, take each of these average points, these 3 points here, and form 3 new vectors. So typically you'll see something like this. You'll see augmented vector right, these are called augmented vectors, is equal to R A right arm minus 1/2 left arm plus left leg, and A VL equals left arm minus 1/2 right arm plus left leg, and then A VF for the foot is equal to left leg minus 1/2 right arm plus left arm. And so these are these augmented vectors that you see people use, and that's kind of like, you know, these 3 vectors here. So you have this sort of 6 different vector quantities that are often used in cardiology. And so that's very simple cardiology with the limbs. And then, of course, additionally, what people do is they add these other electrodes along the chest that I talked about before. And so you would typically take these 4 electrodes and put them at the extremities, near the left leg and right leg and left arm and right arm. And then there's 6 more that you put around near the heart, V1 through V6. And so those are the ones that really are quite useful. And then you get this sort of what's called a 12-lead ECG, but it's really only 10 electrodes that are used to derive it. So thank you very much for watching, and it's been, I hope you've had lots of fun here.